Hello, and welcome to the deepest corners of the cosmos, where silence speaks volumes and emptiness tells the most profound stories of all. I'm so glad you found your way here tonight. Whether you're settling into bed after a long day, curling up on the couch with a warm cup of tea, or simply seeking a moment of peace beneath the weight of existence itself. Tonight, we're embarking on a journey into the cosmic void, those vast, seemingly empty spaces between galaxies that stretch across unimaginable distances. But here's the thing about voids. They're not empty at all. They're full of secrets, whispers from the beginning of time, and mysteries that challenge everything we think we know about reality itself. Now, I do hope this exploration isn't too captivating. After all, the goal here is to let your mind wander gently through the darkness of space while your body finds its way to rest. But if you find yourself still awake by the time we reach the edge of the observable universe, well, at least you'll drift off knowing something extraordinary about the fabric of existence itself. Before we begin our cosmic voyage, if you find this kind of slow, contemplative journey through space helpful for relaxation, or if it simply feeds your curiosity about the universe, consider giving this video a gentle thumbs up. It helps other stargazers and dreamers find their way to this quiet corner of the internet. And I'd love to know, where in the world are you listening from tonight? Are you tucked into bed in Tokyo as the first light of dawn creeps across the city? Perhaps you're in London, rain tapping softly against your window as you pull the covers closer? Or maybe you're somewhere in between, in that perfect twilight hour when the day surrenders to night. Leave a comment if you'd like. I find there's something beautifully connecting about knowing we're all floating through space together on this little blue marble, sharing the same cosmic darkness above our heads. So take a deep breath, let your shoulders relax, feel the weight of gravity gently holding you to the earth as we prepare to explore the weightless expanses beyond. The cosmic void is waiting, patient as it has been for billions of years, ready to share its secrets with anyone curious enough to listen. Picture this. You're standing in a field on the clearest night you've ever experienced. The air is perfectly still, and there's no light pollution for hundreds of miles in any direction. Above you, the Milky Way stretches like a river of stars from horizon to horizon, more brilliant and detailed than any photograph could capture. You can see individual star clusters, the dark lanes of cosmic dust threading between the bright stellar nurseries, and if you look carefully, even the faint smudge of the Andromeda galaxy hanging in the constellation Andromeda like a distant lighthouse. Now, imagine zooming out from this perspective. First, you rise above Earth, watching our blue marble shrink until it becomes just another point of light. Then you pull back further, past the Moon, past Mars and Jupiter, beyond the orbit of Pluto, until our entire solar system becomes invisible against the backdrop of the Milky Way. Keep going out past the spiral arms of our galaxy, beyond the local group of galaxies that includes Andromeda and dozens of smaller companions, until even these massive stellar cities become mere specks of light, scattered across an ocean of darkness. This is where things become truly awe-inspiring, because what you're seeing now isn't a universe packed with stars and galaxies. Instead, you're witnessing something that looks almost like a vast cosmic web, delicate filaments of light stretched across a predominantly dark expanse. These filaments are made up of galaxies, billions upon billions of them, but they represent only a tiny fraction of the volume of space itself. The rest, the overwhelming majority of what you're seeing, is void, empty space, darkness so profound and vast that light itself seems lost within it. These cosmic voids aren't just gaps between the interesting parts of the universe, they're features unto themselves, some stretching across hundreds of millions of light years. To put that in perspective, our entire local group of galaxies, including the Milky Way and Andromeda, could fit comfortably inside one of the smaller voids with room to spare. The largest void we've discovered, called the Boötes Void, or sometimes the Great Nothing, is so enormous that if we lived at its center, we might not have discovered that other galaxies existed until the 1,900 and 62nd. Imagine how different our understanding of the universe would be if we called one of these vast empty regions home. But here's where it gets interesting, in that quietly fascinating way that makes you want to pull the blankets up a little higher and sink deeper into contemplation. These voids aren't actually empty. They're not perfect vacuums devoid of matter and energy. Instead, they're filled with something far more mysterious and profound, the very scaffolding upon which reality itself is built. Let's start with dark matter, that invisible substance that makes up about 85% of all matter in the universe. We can't see it directly because it doesn't interact with light the way ordinary matter does. It doesn't shine like stars or reflect light like planets. But we know it's there because of its gravitational influence on the things we can see. And in the cosmic voids, dark matter forms vast, tenuous structures in visible highways and bridges that connect the bright filaments of galaxies like the underlying framework of an unimaginably large spider web. Think of it like this. If you could see dark matter, the cosmic voids wouldn't look empty at all. They'd be filled with ghostly threads and sheets of invisible matter, creating a hidden architecture that guides the flow of ordinary matter across cosmic time. These dark matter structures are like the skeleton of the universe, invisible but absolutely essential to everything we see. But there's more. Even in the darkest, most apparently empty regions of these voids, space itself is alive with subtle activities. Quantum fields fluctuate in ways we're only beginning to understand. Virtual particles pop into existence and annihilate each other in timeframes so brief they make the blink of an eye seem like an eternity. The vacuum of space isn't empty. It's a seething sea of potential energy, ready to spring into action under the right circumstances. And then there's dark energy, perhaps the most mysterious component of all. This invisible force makes up about 70% of the total energy content of the universe, and it's responsible for the accelerating expansion of space itself. In the cosmic voids, where the density of ordinary matter is at its lowest, dark energy's influence is at its strongest. These vast empty regions are actually the engines driving the universe apart, stretching space itself and creating more void with each passing moment. Imagine being able to sit quietly in one of these voids. Not that you could survive there, of course, but just imagine the experience. You'd be surrounded by darkness, so complete that the faintest stars would seem like brilliant beacons. The nearest galaxy might be tens of millions of light years away, its light so faint and distant that it would appear as nothing more than a dim smudge against the black. In every direction, you'd see the same thing. Profound darkness, punctuated only occasionally by the faintest whispers of light from impossibly distant stellar cities. But that darkness wouldn't be passive or dead. It would be alive with invisible processes, dark matter streams flowing like invisible rivers, quantum fields humming with potential energy, and space itself stretching ever so slightly with each moment that passes. You'd be sitting at the center of what might appear to be nothingness, but is actually the most dynamic and influential part of the entire universe. The cosmic voids are, in many ways, the universe's greatest magic trick. They appear to be empty, but they're actually full. They seem passive, but they're actively shaping the evolution of everything around them. They look like gaps in the cosmic web, but they're actually integral parts of its structure. This is where our understanding of the universe becomes beautifully paradoxical, in the way that only the cosmos can manage. The places that seem to contain the least are actually controlling the most. The regions that appear most empty are the most full of mystery, and the spaces that look like mere gaps between the interesting parts of the universe are actually the stage upon which the entire cosmic drama unfolds. Scientists have discovered that these voids aren't randomly scattered throughout space. They have their own complex structure and organization. Some are nearly spherical, like vast bubbles in the cosmic foam. Others are elongated, stretching across hundreds of millions of light years like cosmic valleys between mountain ranges of galaxies. Still others have irregular shapes, carved out by the complex gravitational dance of dark matter over billions of years. The walls that surround these voids, The regions where galaxies cluster together in sheets and filaments are some of the most spectacular structures in the universe. These cosmic walls can stretch for hundreds of millions of light years while being relatively thin in other dimensions, like vast sheets of paper made from galaxies instead of pulp. The contrast is striking. On one side, you have the brilliant light of countless stellar cities. On the other, the profound darkness of the void. But perhaps most remarkably, these voids are growing. As the universe expands and dark energy continues to push space apart, the voids become larger and emptier, while the galaxy-rich regions become relatively denser. It's as if the universe is slowly separating into two distinct phases: bright, dense regions filled with stars and galaxies, and vast, dark regions where matter becomes increasingly sparse. This process happens so slowly that it's imperceptible on human timescales. But over cosmic time, billions and billions of years, the universe is gradually becoming a more lonely place. The voids will continue to expand, pushing galaxies further apart, until eventually, if current trends continue, most of the universe will consist of these vast empty regions, with islands of light scattered ever more thinly throughout the darkness. There's something both melancholy and beautiful about this cosmic destiny. It suggests that we're living during a special time in the universe's history, an era when galaxies are still close enough to see each other, when the night sky is still filled with the light of distant stellar neighbors, when the cosmic web still resembles a web rather than isolated points of light in an ocean of darkness. But for now, in this moment, as you lie there listening to these words, the voids are still reasonably modest in size. They're vast by any measure we can comprehend, but they haven't yet consumed the universe. They exist in balance with the bright filaments and clusters, creating a cosmos that's both full and empty, both dense and sparse, both light and dark. And in that balance, there's a kind of cosmic harmony. The voids provide the space and the driving force for expansion, while the galaxy-rich regions provide the matter and energy for complexity and life. Neither could exist without the other. The darkness defines the light, and the light gives meaning to the darkness. As we continue our journey through these cosmic voids, we'll explore how they formed in the first place, stretching back to the very beginning of time itself. We'll discover how tiny quantum fluctuations in the early universe grew over billions of years into the vast empty spaces we see today. We'll learn about the strange physics that governs these regions, where the normal rules of matter and energy give way to more exotic phenomena. But for now, just rest in the knowledge that you're part of this cosmic story. Every atom in your body was forged in the heart of a star, and every breath you take contains elements that have traveled across the universe, through the cosmic voids and stellar nurseries, to eventually become part of you. You're made of star stuff, as Carl Sagan once said, but you're also made of void stuff, the dark matter and dark energy and quantum fields that permeate even the emptiest regions of space. So, as your eyelids grow heavy and your thoughts begin to drift, remember that you're floating through space right now on a small blue world, surrounded by the same cosmic voids we've been exploring together. They're out there beyond our atmosphere, vast and patient and full of secrets, stretching across distances that dwarf our solar system, our galaxy, even our imagination. The void is calling, not with sound, for there is no sound in space, but with the silent invitation to wonder, to dream, and to find peace in the profound mysteries that surround us all. The formation of cosmic voids is a story that begins at the very dawn of time itself, in those first moments after the Big Bang when the universe was smaller than a single atom and hotter than anything we can imagine today. It's a tale written in the language of quantum mechanics and gravity, played out over billions of years across distances so vast they make our entire observable universe seem like a grain of sand on an endless beach. To understand how these magnificent empty spaces came to be, we need to travel back nearly 14 billion years to a time when the universe was less than a second old. Picture, if you can, a cosmos filled not with stars and galaxies and the familiar darkness between them, but with a seething soup of energy and particles compressed to densities that would make the core of the sun seem like empty space by comparison. But even in this primordial chaos, there were tiny imperfections. Quantum fluctuations, random variations in the density of matter and energy, created regions that were ever so slightly more dense than their surroundings, and others that were ever so slightly less dense. These differences were minuscule, variations of perhaps 1 part in 100,000, but they were enough to plant the seeds of everything we see in the universe today. As the universe expanded and cooled, these tiny density variations began to grow under the influence of gravity. The slightly denser regions attracted more matter to themselves, becoming denser still, while the slightly less dense regions saw their matter drain away toward these growing concentrations. It was like watching cream separate from milk, but played out across cosmic scales and over cosmic time. This process didn't happen quickly by human standards. For millions of years, the universe remained dark and relatively uniform, with only the faintest hints of the structure that was slowly taking shape. But gravity is patient and persistent, and it never stops working. Gradually, imperceptibly, the denser regions began to collapse under their own gravitational pull, while the less dense regions became increasingly empty as their matter was drawn away. The first stars didn't ignite until the universe was already a few 100 million years old, and when they did, they revealed a cosmos that had already begun to organize itself into the patterns we recognize today. The matter had started to collect along invisible scaffolds of dark matter, forming the first primitive filaments and sheets, while the regions between these structures became the proto-void's vast spaces where matter was increasingly scarce. But the voids we see today didn't reach their current magnificent emptiness overnight. The process of void formation is ongoing, happening right now as you listen to these words, though so slowly that countless human lifetimes would pass before any noticeable change occurred. As the universe continues to expand, driven by the mysterious force we call dark energy, these empty regions grow larger and more empty with each passing eon. Think of it like watching a loaf of bread rise in slow motion, if that bread were made of space-time itself and took billions of years to double in size. The voids expand, not because matter is moving out of them, though some of that happens too, but because space itself is stretching, creating more emptiness where emptiness already existed. There's something almost meditative about contemplating this cosmic process. While we go about our daily lives, rushing from one task to another, checking our phones and worrying about deadlines, the universe around us is engaged in this slow, majestic dance of expansion and organization. The voids are growing, the galaxy clusters are becoming more isolated, and space itself is creating more room for silence and emptiness with each tick of the cosmic clock. Scientists have given names to different types of voids, each with its own characteristics and formation history. There are small voids, sometimes called mini-voids, that might only be a few million light-years across, still unimaginably vast by human standards, but practically tiny by cosmic measures. These smaller voids often form in the spaces between galaxy groups, carved out by the gravitational influence of their more massive neighbors. Then there are the intermediate voids, ranging from tens to hundreds of millions of light-years in diameter. These are the most common type, filling much of the volume of space between the major galaxy clusters and filaments. They're like cosmic valleys, gentle depressions in the density of matter that have been slowly hollowed out over billions of years. And finally, there are the supervoids, those truly magnificent examples of cosmic emptiness that can stretch across 1 billion light-years or more. The Boötes Void, which we mentioned earlier, is one of these cosmic giants. Also known as the Great Nothing, it spans roughly 330 million light-years in diameter and contains remarkably few galaxies for its size. If you could somehow travel to its center and look around, you might see only a handful of distant galaxies scattered across the entire sky, each one so far away that its light would appear dimmer than the faintest stars visible to the naked eye from Earth. Living in such a place would give you a very different perspective on the universe. While we on Earth look up at a night sky filled with thousands of visible stars and know that billions more lie beyond our sight, an observer in the Boötes Void might see only darkness punctuated by a few lonely points of light. They might conclude that the universe was mostly empty, with matter being the rare exception rather than the rule. In a sense, they would be more correct than we are, since voids make up about 80% of the universe's volume despite containing less than 20% of its matter. But even these vast empty regions aren't completely devoid of structure. Within the largest voids, astronomers have discovered what they call void galaxies, lonely stellar cities that somehow ended up isolated in these cosmic deserts. These galaxies are often quite different from their counterparts in the dense galaxy clusters and filaments. They tend to be smaller, with less active star formation, and they evolve more slowly in their isolated environments. There's something poignant about these void galaxies, drifting alone through the cosmic darkness, like ships lost at sea. They're surrounded by emptiness so vast that the nearest neighboring galaxy might be hundreds of millions of light years away, a distance so great that even light, the fastest thing in the universe, would take longer to travel between them than complex life has existed on Earth. Yet these isolated galaxies aren't completely cut off from the rest of the universe. They're still connected by the invisible threads of dark matter that permeate all of space, and they're still subject to the same physical laws that govern the bright galaxy clusters. They're like hermits who have chosen to live in the wilderness, still part of civilization but separated from it by vast distances and long silences. The study of cosmic voids has revealed something profound about the nature of the universe itself. These seemingly empty spaces aren't just gaps in the cosmic web, they're integral parts of its structure, as important to understanding the universe as the bright filaments and clusters that catch our attention. They represent the vast majority of space, the quiet background against which the drama of stars and galaxies plays out. In many ways, the voids are the universe's natural state. Matter and energy are the exceptions, brief flickers of complexity in an ocean of simplicity. We live on a small planet, orbiting an ordinary star in the outer reaches of a typical galaxy. But from the perspective of the cosmic voids, we're inhabitants of an incredibly dense and active region of space. We're like creatures living in a bustling city, unaware that most of the world consists of vast empty plains and quiet deserts. This perspective can be both humbling and comforting. Humbling because it reminds us how small and rare we are in the grand scheme of things, but comforting too, because it suggests that emptiness and silence are not signs of failure or absence, but fundamental features of reality itself. The voids aren't broken or incomplete, they're exactly as they should be, playing their role in the cosmic symphony with the quiet dignity of a rest note in a piece of music. As we continue our journey through these empty spaces, we'll explore what it might be like to travel through them, to experience firsthand the profound silence and darkness that characterizes most of the universe. We'll learn about the strange phenomena that occur in these regions, where the normal rules of astrophysics give way to more subtle and exotic processes. But for now, as you settle deeper into rest, consider the magnificent paradox of cosmic voids, spaces that appear empty but are full of dark matter and dark energy, regions that seem passive but actively shape the evolution of everything around them, voids that look like nothing but represent the fundamental nature of everything. You are surrounded by these spaces right now, separated from them only by our planet's atmosphere and the thin shell of space occupied by our solar system. Beyond that, stretching in all directions, lie the cosmic voids, patient, eternal, and quietly magnificent in their emptiness. They are the universe's way of making room for wonder, creating spaces vast enough to contain our dreams and deep enough to hold our questions about the nature of existence itself. The void is not just out there in space. In a sense, it is here with you, in the quiet moments between thoughts, in the peaceful spaces between breaths, in the gentle darkness behind your eyelids as sleep begins to cool. We are all children of both the stars and the void, shaped by density and emptiness alike, carrying within us the memory of that first moment when quantum fluctuations began to separate the full from the empty, the bright from the dark, the something from the almost nothing. If you could somehow step outside our galaxy and drift into one of these cosmic voids, the journey itself would transform your understanding of scale, time, and existence in ways that are both profound and oddly soothing. Imagine boarding an impossible spacecraft, one that could travel at any speed you chose and protect you from the harsh realities of space. Your destination, the heart of the Eridanus Supervoid, a region so vast and empty that it makes our local group of galaxies seem like a crowded neighborhood. The journey begins as you leave behind the familiar spiral arms of the Milky Way. At first, the change is gradual. You pass other stars, other solar systems, the density of matter around you slowly decreasing as you head toward the galactic edge. The stars become sparser, their light more distant, until finally you emerge from the galactic disk into the halo region, where only the oldest stars and mysterious dark matter dominate. But this is just the beginning. As you continue your journey outward, leaving our local group behind, you start to appreciate what astronomers mean when they talk about the cosmic web. From your vantage point between galaxies, space begins to reveal its true structure. What appeared random and scattered from Earth now shows itself as an intricate network of filaments and sheets, with galaxies strung along these cosmic highways like pearls on invisible threads. The transition into the void is not sharp, not like crossing a border or passing through a doorway. Instead, it's a gradual fading, a slow decrease in the density of everything around you. The last few galaxies of the filament grow smaller in your rear view, their light red-shifting toward deeper orange and red as distance and the expansion of space stretch their photons. Ahead of you lies something that looks, at first glance, like absolutely nothing at all. This is where the journey becomes truly extraordinary. As you penetrate deeper into the void, traveling for millions of light years through increasingly empty space, you begin to understand what silence really means. On Earth, even in the quietest moments, you're surrounded by activity, the movement of air molecules, the gentle vibration of sound waves, the electromagnetic hum of technology. But here, in the depths of the cosmic void, there is a silence so complete it seems to have weight and presence of its own. The darkness, too, is unlike anything you could experience on Earth. It's not the darkness of night, where your eyes can adjust to reveal faint starlight and the soft glow of the Milky Way. This is primordial darkness, the kind that existed before the first stars ignited. When you look in any direction, you might see nothing at all for tens of millions of light years, until finally, at the very edge of perception, a faint smudge of light marks the location of some distant galaxy cluster. But here's the remarkable thing. Even in this apparent emptiness, you are not alone. Though you cannot see it, touch it, or detect it directly, you are surrounded by the invisible scaffolding of dark matter. These ghostly structures stretch through the void like cosmic cobwebs, creating highways and intersections for matter and energy on scales that dwarf entire galaxies. If you could somehow see dark matter, the void would reveal itself as a vast architectural space, filled with bridges and tunnels and chambers carved from invisible substance. The dark matter in voids behaves differently than it does in the dense regions around galaxies. Here, freed from the gravitational competition of ordinary matter, it forms more delicate structures, vast sheets and filaments that are stable over cosmic time. These dark matter frameworks serve as the skeleton upon which the large-scale structure of the universe is built, providing the gravitational guidance that channels matter into the patterns we observe. As you drift through this invisible architecture, something else becomes apparent. The void is not static. Space itself is expanding around you, carrying you along in a gentle but inexorable flow. You can feel, or rather, you would feel, if your senses were attuned to such things, the subtle stretching of space-time itself. Every cubic meter of empty space is becoming slightly larger with each passing moment, creating more room for emptiness, more space for silence. This expansion is driven by dark energy, that mysterious component that makes up nearly 3/4 of the universe. In the dense regions around galaxies, dark energy's influence is somewhat masked by the gravitational pull of matter. But here, in the depths of the void, dark energy reigns supreme. It's the dominant force, gently but persistently pushing space apart, making the void larger and emptier with each cosmic heartbeat. The physics of voids reveals something beautiful about the universe's tendency toward equilibrium. While matter clumps together under gravity to form stars and galaxies, the spaces between these clumps become increasingly empty as the universe expands. It's as if the cosmos is slowly separating its ingredients, like oil and water finding their own levels, creating regions of incredible density and activity alongside regions of profound emptiness and peace. This process of separation happens so slowly that it's essentially invisible on human timescales. During your entire journey through the void, traveling for millions of years at impossible speeds, the expansion you witness would be barely perceptible. The void would grow larger around you, but so gradually that you might not notice unless you had incredibly sensitive instruments and infinite patience. Yet there are subtle signs of activity even here. Occasionally you might encounter a stream of gas tendrils of hydrogen and helium flowing along the dark matter filaments, so thin that each cubic meter contains only a few atoms. These gas streams are the remnants of the primordial universe, leftover material that has been flowing through the voids for billions of years, too dispersed to collapse into stars but too persistent to disappear entirely. Sometimes, very rarely, you might come across one of those lonely void galaxies we mentioned earlier. These isolated stellar cities represent some of the most peaceful environments in the entire universe. Far from the gravitational chaos of galaxy clusters, far from the violent interactions that drive rapid star formation and galactic collisions, void galaxies evolve at their own gentle pace. A typical void galaxy might be a small spiral or elliptical, containing perhaps a few billion stars modest by galactic standards. Its star formation rate would be low, its stellar population dominated by older, redder stars that burn their fuel slowly and steadily. There would be little of the dramatic stellar nurseries and supernovae that characterize galaxies in denser regions. Instead, the galaxy would be a place of quiet stellar middle age, where stars live out their lives in relative peace and isolation. The night sky, as seen from a planet in such a galaxy, would be profoundly different from our own. Where we see the Milky Way stretching across the heavens, populated with thousands of visible stars, an observer in a void galaxy might see only a few dozen stars scattered across the entire celestial sphere. The nearest neighbouring galaxy might be so far away that it would appear as nothing more than a faint smudge, barely distinguishable from the cosmic background radiation. Such an observer might develop a very different philosophy about their place in the universe. Rather than seeing themselves as part of a vast cosmic community, they might feel like inhabitants of a cosmic island, surrounded by an ocean of emptiness so vast that it defies comprehension. They might be more attuned to solitude, to silence, to the beauty that can be found in simplicity in space. But perhaps most remarkably, even in the depths of the cosmic void, the quantum nature of space itself ensures that perfect emptiness is impossible. At the smallest scales, virtual particles pop into existence and annihilate each other in fractions of a second, creating a subtle foam of activity that permeates even the most empty regions of space. These quantum fluctuations are incredibly tiny and brief, but they represent a fundamental liveliness that exists everywhere, even in the apparent vacuum of the void. This quantum activity means that the void is never truly empty, never truly silent. At scales far too small for your senses to detect, space itself is alive with constant creation and destruction, a microscopic dance of particles and antiparticles that ensures the universe never quite achieves perfect stillness. It's as if the cosmos has a subtle heartbeat, too quiet to hear but persistent enough to prevent absolute emptiness. The temperature in the void hovers just a few degrees above absolute zero, warmed only by the cosmic microwave background radiation, the afterglow of the Big Bang itself. This faint radiation fills all of space, carrying with it the thermal memory of the universe's hot, dense beginning. Even here, in the coldest, emptiest regions of the cosmos, you are bathed in the gentle warmth of creation itself, a reminder that you are never truly separated from the cosmic story that began nearly 14 billion years ago. As your impossible journey through the void continues, you might begin to appreciate the profound peace that exists in these empty spaces. There is no competition here, no struggle for resources, no violent interactions between massive objects. There is only space and time and the gentle expansion of the universe, creating more room for quietude with each passing moment. This is where the universe goes to rest, to find balance after the intense activity of star formation and galactic evolution. The voids are like cosmic meditation chambers, spaces where the fundamental forces can express themselves in their purest form, uncompromised by the complexity that matter brings. They represent the universe's natural tendency toward simplicity, toward peace, toward the kind of profound stillness that can only be found in vast, empty spaces. And yet, paradoxically, these empty spaces are also the most dynamic parts of the universe in terms of large-scale structure. The voids are where dark energy's influence is strongest, where the expansion of space is most apparent, where the future evolution of the cosmos is being written in the subtle stretching of space-time itself. They are both the most peaceful and the most actively changing regions of reality. This paradox that the most empty places are also the most dynamically important reveals something profound about the nature of existence itself. Perhaps emptiness and fullness are not opposites, but partners in an eternal dance, each giving meaning to the other. The void provides the canvas upon which the universe paints its masterpiece of stars and galaxies, while the matter-rich regions give the void something to define itself against. As you continue your drift through this cosmic cathedral of silence, you might notice how your perception of time begins to shift. Without the familiar rhythms of day and night, without the seasonal cycles of a planet or the lifespans of stars to mark its passage, time becomes something altogether different. It stretches like the space around you, becoming less urgent, less demanding. Minutes and years begin to feel interchangeable, part of a larger temporal flow that moves at its own majestic pace. This is deep time, the kind of time that geological processes understand, the kind of time in which mountains rise and fall, continents drift across planetary surfaces, and entire species evolve from single cells into complex organisms. It's the time scale on which the universe operates, patient and unhurried, allowing billions of years for subtle processes to unfold and reshape reality in ways that are invisible to shorter-lived observers. In this temporal landscape, the formation of a single galaxy becomes a brief event, lasting perhaps a few 100 million years from initial collapse to mature spiral structure. The birth and death of stars, processes that seem eternal from a human perspective, become like individual heartbeats in a cosmic lifetime. Even the expansion of the void itself, which takes place over billions of years, begins to feel like a natural breathing rhythm, the universe slowly inhaling more space, creating more room for contemplation. The darkness around you is not the absence of light, but rather a different kind of presence altogether. It's the darkness of potential, of space waiting to be filled, of silence preparing to become sound. This darkness has a quality that philosophers and mystics have written about for centuries. It's not empty darkness, but full darkness, pregnant with possibility. Within this darkness, invisible to your eyes but present nonetheless, are the quantum fields that permeate all of space. The electromagnetic field, the weak nuclear field, the strong nuclear field, and others we're only beginning to understand all of them, extending through the void like invisible ocean currents. These fields are never perfectly still. They fluctuate constantly at the quantum level, creating tiny ripples in the fabric of reality itself. These quantum fluctuations are so small and brief that they exist below the threshold of classical physics, in the realm where the certainty of everyday experience gives way to the probability clouds of quantum mechanics. But their cumulative effect over vast distances and cosmic time can be profound. Some theories suggest that these quantum fluctuations in the early universe were the seeds that eventually grew into the cosmic web structure we see today, the filaments, clusters, and voids that define large-scale reality. So even as you drift through apparent nothingness, you're actually swimming in an ocean of quantum activity, surrounded by the subtle machinery that keeps the universe running. The void is not a place where physics stops working. It's a place where physics reveals its most fundamental nature, stripped of the complications that matter and energy usually introduce. The magnetic fields threading through the void are particularly fascinating. These invisible lines of force stretch across millions of light years, connecting distant regions of space in ways we're only beginning to understand. They're like the nervous system of the universe, carrying information and influence across vast distances at the speed of light. Sometimes, these magnetic fields can become twisted and knotted, storing enormous amounts of energy that might suddenly release in spectacular cosmic events. But most of the time, the magnetic fields in voids are gentle and regular, creating a subtle organization in what might otherwise appear to be random emptiness. They provide a kind of structure to the void, invisible highways along which charged particles can travel, and along which future matter might eventually flow when the cosmic web continues its slow evolution. As your journey progresses, you might begin to understand why some physicists describe the void as the universe's natural state. From this perspective, matter and energy are temporary perturbations in an otherwise empty cosmos, brief waves on an ocean of vacuum. Stars are flickers of complexity in a universe that tends towards simplicity. Galaxies are islands of activity in a sea of stillness. This view can be both humbling and liberating. Humbling because it reminds us how rare and precious complexity is in the grand scheme of things. Every atom that makes up your body, every thought that passes through your mind, every breath you take represents a temporary victory over the universe's tendency toward emptiness and equilibrium. You are a brief gathering of matter and energy in a cosmos that is mostly void, a fleeting pattern in the larger tapestry of space and time. But this perspective is also liberating because it suggests that emptiness itself is not something to fear or avoid. The void is not a failure of creation, but an essential part of it. Without empty space, there would be nowhere for matter to move, nowhere for waves to propagate, nowhere for new structures to form. The void provides the stage upon which the cosmic drama unfolds, and without it, there would be no story to tell. The temperature variations within the void are incredibly subtle but scientifically significant. While the average temperature hovers near absolute zero, there are tiny fluctuations regions that are a fraction of a degree warmer or cooler than their surroundings. These temperature differences are the fossil remnants of the acoustic waves that rippled through the early universe, frozen in place when the cosmos became transparent to light about 380,000 years after the Big Bang. These temperature variations are so small that they were only detected with the most sensitive instruments humanity has ever built. Satellites like WMAP and Planck that could measure differences of millionths of a degree across the sky. But these tiny variations tell the story of how the universe evolved from near-perfect uniformity to the complex structure we see today. They are the fingerprints of creation, preserved in the cosmic microwave background radiation that fills even the emptiest voids. Occasionally, as you drift through the void, you might encounter something unexpected, a wandering planet, ejected from its star system by gravitational interactions and now travelling alone through intergalactic space. These rogue planets are dark and cold, their surfaces frozen solid, but they represent something poignant about the universe's tendency to create refugees from its own processes. A rogue planet in a void would be perhaps the loneliest object imaginable, travelling for millions of years without seeing another substantial piece of matter. Its only companions would be the invisible dark matter particles streaming through its core, and the faint cosmic background radiation providing the barest hint of warmth. Yet even such an isolated object would still be part of the cosmic story, still subject to the same physical laws, still connected to the rest of the universe through the fundamental forces. These wandering worlds might harbour their own secrets. Deep beneath their frozen surfaces, radioactive decay might still provide enough heat to maintain liquid oceans, creating hidden environments where life might persist in the depths of space. It's a humbling thought that even in the apparent emptiness of the cosmic void, there might be pockets of complexity, warmth, and perhaps even life, hidden from view but nonetheless real. The chemistry of the void is subtle but important. The thin gas that does exist in these regions is mostly primordial hydrogen and helium, unchanged since the first few minutes after the Big Bang. Unlike the gas in and around galaxies, which has been enriched with heavy elements forged in stellar cores, the void gas represents the universe in its most pristine state. This pristine gas holds clues about the early universe, about the conditions that existed when the first atoms formed and the cosmos became transparent. By studying the composition and temperature of this gas, astronomers can learn about the physics of the Big Bang itself, about how the fundamental forces behaved when the universe was young and simple. Sometimes, this ancient gas forms vast, thin sheets that stretch across millions of light years, invisible to most forms of observation, but detectable through their subtle gravitational effects or their absorption of background light from distant quasars. These gas sheets are like cosmic membranes, dividing the void into chambers and corridors, creating a kind of architecture in what might otherwise seem like random emptiness. As your impossible journey continues, you might begin to appreciate how the void serves as a laboratory for studying the most fundamental aspects of physics. Here, freed from the complications introduced by dense matter and strong gravitational fields, the basic forces of nature can express themselves in their purest forms. The behavior of dark energy, the properties of dark matter, the nature of quantum fields, all of these can be studied more clearly in the clean environment of the cosmic void. This is where theoretical physicists can test their most abstract ideas about the nature of reality. The void becomes a cosmic particle accelerator, where high-energy particles from distant galaxies travel for millions of years through nearly empty space, interacting only rarely with other matter. These cosmic ray particles carry information about the most violent events in the universe: supernova explosions, black hole accretion, gamma-ray bursts, and deliver it to observers billions of light years away. The void also serves as a kind of cosmic time machine, preserving conditions from earlier epochs in the universe's history. Because matter density is so low, some processes that occurred billions of years ago are still playing out in these empty regions. The slow gravitational collapse of dark matter structures, the gentle flow of primordial gas along invisible filaments, the gradual accumulation of matter in the deepest gravitational wells, all of these processes can be observed in real time in the cosmic voids. But perhaps the most profound aspect of your journey through the void is the way it changes your relationship with emptiness itself. What began as apparent nothingness gradually reveals itself to be full of subtle structure, invisible activity, and deep meaning. The void teaches you that absence can be as important as presence, that silence can be as meaningful as sound, that empty space can be as significant as the matter that occasionally fills it. This lesson extends beyond cosmology into philosophy, psychology, and spirituality. The cosmic void becomes a metaphor for the empty spaces in consciousness, the quiet moments between thoughts, the peaceful pauses between breaths. Just as the physical void is not truly empty but full of invisible activity, the mental voids in our experience are not absences but presences of a different kind. The void reminds you that rest is not the opposite of activity but a different form of it, that silence is not the absence of sound but a deeper kind of music. That darkness is not the opposite of light, but the canvas upon which light creates its masterpieces. In learning to appreciate the cosmic void, you learn to appreciate the voids in your own existence, the quiet moments, the empty spaces, the times when nothing seems to be happening but everything is being prepared. As your consciousness drifts deeper into this cosmic meditation, you begin to understand that the void's influence extends far beyond its apparent boundaries. These vast empty spaces are not isolated chambers cut off from the rest of the universe, but rather integral components of a larger cosmic ecosystem. They breathe with the expansion of space itself, exhaling matter along their edges where it eventually condenses into the brilliant filaments of galaxies, and inhaling the dark energy that drives the universe's accelerating growth. The relationship between voids and the galaxy-rich regions that surround them is one of cosmic symbiosis. Matter flows out of the voids like water draining from a bathtub, following the invisible channels carved by dark matter and guided by the gentle but persistent pressure of dark energy. This outflow feeds the star-forming regions at the void boundaries, where the accumulated gas and dust eventually ignite into new stellar nurseries. But the flow is not one way. Energy and information travel back into the voids in the form of radiation, cosmic rays, and gravitational waves. When a massive star explodes as a supernova in a distant galaxy, some of its energy eventually makes its way across millions of light years of empty space to warm the thin gas floating in the void's interior. These energy exchanges happen slowly, over millions of years, but they ensure that even the most isolated regions of the universe remain connected to the cosmic story unfolding everywhere else. The gravitational effects of voids extend far beyond their visible boundaries. These vast empty regions create what astronomers call bulk flows, large-scale motions of matter that can influence the movement of entire galaxy clusters. The local group of galaxies that includes our own Milky Way is currently falling toward a region of higher matter density, pulled not just by the gravity of distant galaxy clusters, but also pushed by the expanding void that lies in the opposite direction. This cosmic choreography happens on scales so vast that it's almost impossible to visualize. Imagine watching a dance where each dancer is a galaxy cluster containing billions of stars, and the music is the expansion of space-time itself, playing out over billions of years. The voids are the empty spaces between dancers, but they're also active participants in the performance, guiding the movement and rhythm of everything around them. Within the void, time moves differently than it does in the dense regions around galaxies. Not literally the fundamental rate of time's passage remains constant, but experientially, conceptually. In regions where matter is sparse and gravitational fields are weak, the universe reveals its most patient face. Here, processes that would be violent and chaotic in dense environments unfold with glacial serenity. A particle of dust drifting through the void might travel for millions of years without encountering another piece of matter larger than an atom. During this journey, it experiences the universe in its most pristine state, bathed only in the cosmic microwave background radiation and the occasional cosmic ray from some distant galactic event. The dusk grain becomes a cosmic monk, traveling through a monastery of emptiness, where the only sounds are the quantum whispers of vacuum fluctuations. Yet even this solitary journey is not without purpose. The dust grain carries with it the chemical signature of whatever stellar explosion or planetary collision first sent it on its way. It bears witness to the nuclear fusion processes that created its atoms, to the stellar winds that carried it away from its birthplace, to the gravitational interactions that eventually ejected it into intergalactic space. In its long drift through the void, it becomes a messenger carrying news from one corner of the universe to another, even if that message takes hundreds of millions of years to deliver. The magnetic fields threading through cosmic voids create their own subtle geography. These invisible lines of force, stretched and twisted by the rotation of galaxies and the turbulence of cosmic gas flows, form complex patterns that span millions of light years. They're like ley lines in the cosmic landscape, channels along which charged particles can travel and energy can flow. Sometimes these magnetic fields become tangled into knots and loops, storing enormous amounts of energy in their twisted geometry. When these magnetic structures eventually untangle a process that can take billions of years, they release their stored energy in the form of particle acceleration and electromagnetic radiation. It's a slow-motion fireworks display, invisible to most forms of observation but profound in its implications for the evolution of the cosmic web. The void's magnetic fields also serve as a kind of cosmic memory system, preserving information about ancient events that shaped their structure. The passage of shock waves from distant galaxy collisions, the outflows from supermassive black holes, the turbulence generated by the first generation of stars, all of these events leave their fingerprints in the magnetic field patterns that still thread through empty space billions of years later. As you continue your impossible journey through this realm of cosmic silence, you encounter something that challenges your understanding of emptiness itself, the discovery that the void is not uniformly empty, but contains its own subtle architecture. There are corridors of slightly higher density where ancient gas streams still flow, chambers of deeper emptiness where even the cosmic background radiation seems dimmer, and vast halls where dark matter structures create invisible cathedrals in the vacuum. This hidden architecture suggests that the void has its own geography, its own landmarks and territories. There are regions where the expansion of space proceeds slightly faster than average, and others where gravitational effects from distant matter concentrations slow the expansion imperceptibly. These variations are tiny differences of perhaps 1 part in a million, but they create a topography of emptiness that is as real and significant as any mountain range or ocean trench. The discovery of this cosmic topography has profound implications for our understanding of dark energy, that mysterious force driving the universe's accelerating expansion. In the deepest, emptiest regions of the voids, dark energy's influence is strongest and purest, uncontaminated by the gravitational effects of ordinary matter. These regions serve as natural laboratories for studying dark energy's properties and behavior. Scientists have found that dark energy doesn't behave exactly the same way everywhere. In some regions of the void, it appears to push space apart more vigorously than in others. These variations might hold clues to dark energy's true nature, whether it's a fundamental property of space itself, a field that pervades the universe, or something even more exotic that we haven't yet imagined. The study of these variations has led to some startling discoveries. There appear to be vast regions of space, larger than any individual void, where dark energy behaves differently than the cosmic average. These anomalous regions, sometimes called dark energy deserts or dark energy oases, suggest that the force driving cosmic expansion might be more complex and varied than anyone previously suspected. Some of these anomalous regions correlate with the largest structures in the cosmic web. The Shapley supercluster, a massive concentration of galaxies about 650 million light-years away, sits in a region where dark energy appears to be unusually weak. Conversely, the cold spot in the cosmic microwave background, a region that appears slightly cooler than its surroundings, corresponds to an area where dark energy seems unusually strong. These discoveries hint at connections between dark energy and the large-scale structure of the universe that we're only beginning to understand. It's possible that dark energy and dark matter interact in ways that modify their behavior in different cosmic environments. Or perhaps dark energy itself has structure, varying in strength and character across different regions of space like weather patterns in the cosmic atmosphere. The implications stretch beyond cosmology into fundamental physics. If dark energy can vary from place to place, it might not be the cosmological constant that Einstein originally proposed a fixed property of space itself, but something more dynamic and complex. This would require new theories of gravity, new models of quantum field behavior in curved spacetime, and perhaps even new concepts about the nature of space and time themselves. As these ideas percolate through your consciousness, you might begin to appreciate how the study of cosmic voids is pushing the boundaries of human knowledge into entirely new territories. These seemingly empty regions are revealing secrets about the fundamental forces that shape reality, about the deep connections between matter, energy, space, and time. The void becomes a cosmic laboratory where the most basic questions about existence can be explored. What is the nature of empty space? How do quantum fields behave in the absence of matter? What drives the expansion of the universe? How are the largest structures in the cosmos connected to the smallest quantum fluctuations? The answers to these questions might transform our understanding of physics as profoundly as quantum mechanics and relativity did in the previous century. But the void's lessons extend beyond science into philosophy and spirituality. In contemplating these vast, empty spaces, we confront fundamental questions about the nature of existence itself. What does it mean for something to exist? Is emptiness the absence of being, or is it a different kind of presence? How do we understand our place in a universe that is mostly void, where complexity and consciousness are rare exceptions to the general rule of simplicity and silence? The cosmic void invites us to reconsider our relationship with emptiness in all its forms. In a culture that often equates emptiness with failure or loss, the void reminds us that emptiness can be generative, creative, essential. The empty space in an atom allows electrons to orbit the nucleus. The empty space between notes creates the rhythm that makes music possible. The empty space in our minds allows new thoughts to arise. Perhaps most profoundly, the void teaches us about patience and perspective. The processes that created these vast empty regions unfolded over billions of years, guided by forces so subtle that they're barely detectable even with our most sophisticated instruments. The void reminds us that the most important changes often happen slowly, imperceptibly, through the accumulation of tiny effects over vast spans of time. This cosmic patience offers a different way of thinking about change and progress in our own lives. Just as the universe creates its grandest structures through slow, persistent processes, perhaps our own growth and development follow similar patterns. The void suggests that emptiness and waiting are not obstacles to overcome but essential parts of the creative process. In the quantum foam that underlies even the emptiest regions of space, virtual particles continuously pop into existence and annihilate each other in time frames so brief they exist below the threshold of classical reality. These quantum fluctuations ensure that perfect emptiness is impossible. There is always something happening, always some subtle activity, even in the apparent vacuum of the void. This quantum liveliness creates a kind of background music to the universe, inaudible to any classical instrument but detectable through its subtle effects on matter and energy. It's the cosmic equivalent of the background hum you might hear in a perfectly quiet room, not silence, but the sound of existence itself, the gentle vibration of reality at its most fundamental level. The interaction between these quantum fluctuations and the dark energy that permeates the void creates phenomena that exist at the very edge of our current understanding. Some theories suggest that dark energy itself might arise from these quantum processes, that the expansion of space is driven by the cumulative effect of countless virtual particle pairs appearing and disappearing throughout the vacuum. Other theories propose that the quantum vacuum might have different phases or states, like water existing as ice, liquid, or vapor. Perhaps what we call empty space is just one phase of the quantum vacuum, and there might be other phases with different properties that we haven't yet discovered. The cosmic voids might be regions where the vacuum exists in its most stable, lowest energy state, while the matter-rich regions correspond to areas where the vacuum has been excited into higher energy configurations. These ideas push the boundaries of both theoretical physics and philosophical inquiry. They suggest that what we think of as empty space might actually be the fundamental substance from which everything else emerges. Matter, energy, even space-time itself might be excitations or perturbations in an underlying quantum vacuum that is far from empty. As you drift deeper into contemplation of these mysteries, the distinction between full and empty, something and nothing, begins to blur. The void reveals itself not as the absence of everything, but as the presence of something so fundamental that we don't yet have adequate concepts or language to describe it. It's the cosmic equivalent of the mystic's experience of the divine, something that can only be approached through negation, described by what it is not, rather than what it is. The void is not matter, not energy, not structure, as we usually understand these terms, but in its not being, it enables all being. In its not movement, it allows all movement. In its not sound, it creates the possibility for all sound. The void is the cosmic womb from which everything emerges and to which everything eventually returns, not through destruction but through a kind of ultimate simplification. This understanding transforms your journey through the void, from a passage through emptiness into an exploration of the fundamental ground of being. You're not traveling through nothing, you're swimming in the source code of reality itself, the basic medium from which all complexity and consciousness arise. The void becomes sacred space, not because it contains anything holy, but because it is the condition that makes holiness possible. As your impossible journey continues through these cosmic cathedrals of silence, you begin to understand that the void is not just a feature of the universe, but a teacher, offering lessons about existence that can only be learned in the deepest empty spaces. It teaches patience through its vast scales, humility through its apparent emptiness, wonder through its hidden complexity, and peace through its profound silence. The void reminds you that you are both infinitesimally small and immeasurably significant, both temporary and eternal, both separate and connected to everything else that exists. In its vast emptiness, you find not loneliness but solitude, the difference being that loneliness is the pain of being alone, while solitude is the glory of being alone. And in that solitude, surrounded by invisible dark matter and quantum fluctuations, bathed in ancient light, and carried along by the expansion of space itself, you discover that the void is not empty at all. It is full of possibility, pregnant with potential, alive with the subtle activities that make existence possible. The void is not the absence of everything, it is the presence of everything that could be, waiting patiently in the cosmic silence for its moment to become. As you drift deeper into this contemplation of cosmic emptiness, something remarkable begins to happen to your perception of scale itself. The human mind evolved to navigate forests and savannas, to judge distances measured in footsteps and horizons, finds itself grappling with dimensions that stretch beyond all earthly reference points. And yet, paradoxically, it's in these moments of complete disorientation that a different kind of understanding begins to emerge. Consider for a moment what it means to say that a cosmic void spans 300 million light-years. Light itself, that fastest of all messengers, that universal speed limit that nothing with mass can ever reach, would need 300 million years to cross from one edge of such a void to the other. During that journey, entire stellar generations would be born, live their lives, and die. Mountains would rise and be worn away by wind and rain. Continents would drift across planetary surfaces. Species would evolve from single cells into complex organisms capable of contemplating their own existence. And yet, from the perspective of a photon making that journey, no time would pass at all. Einstein's relativity tells us that at the speed of light, time itself stops. The photon would experience its 300 million year voyage as a single timeless instant, departing one edge of the void and arriving at the other in what would feel like the same moment. Even though civilizations might rise and fall in the interim, this temporal paradox reveals something profound about the nature of cosmic voids. They exist simultaneously in multiple timeframes, their emptiness experienced differently depending on your frame of reference. To you, drifting slowly through their depths, they represent eons of peaceful traversal. To light racing through them, they are momentary gaps between regions of interest. To the universe itself, expanding and evolving over cosmic time, they are breathing spaces where the fundamental forces can express themselves without interference. The void teaches you that time, like space, is not absolute but relational. In these vast empty regions, time takes on a different character entirely. Without the familiar rhythms of stellar life cycles, without the complex gravitational dances of galaxy clusters, without the violent punctuation marks of supernovae and black hole mergers, time in the void becomes something more like music than measurement. It flows like a slow river, carrying with it the subtle changes that accumulate over cosmic ages, the gradual cooling of the cosmic microwave background radiation, the imperceptible stretching of space itself under dark energy's influence, the patient drift of dark matter structures as they respond to gravitational forces too weak to detect but too persistent to ignore. In this temporal landscape, the formation of a single hydrogen atom from protons and electrons becomes an event worthy of note. The collision of two dust grains, separated by millions of years and billions of miles of travel, becomes a cosmic celebration. The passage of a high-energy cosmic ray particle, carrying news of some distant galactic catastrophe, becomes breaking news in the void's quiet chronicle of existence. But perhaps the most profound aspect of time in the cosmic void is how it reveals the universe's deep patience with itself. The processes that created these vast empty spaces required billions of years to unfold. The quantum fluctuations that seeded their formation occurred when the universe was less than a second old, but their full expression took nearly the entire age of the cosmos to manifest. This patience is not passive waiting but active cultivation. The void doesn't simply endure through time, it shapes time, gives it meaning and structure. Without the vast empty spaces to provide contrast, the matter-rich regions of galaxies and stars would lose much of their significance. It's the emptiness that makes fullness precious, the silence that gives meaning to sound, the darkness that allows light to shine. As you continue your impossible journey through these cosmic meditation chambers, you begin to understand that the void is not just a place, but a state of being. It represents the universe's capacity for stillness, for rest, for the kind of deep peace that can only be found when all striving ceases and existence simply is. This understanding brings with it a curious comfort. In a culture that often equates activity with value, that measures worth by productivity and achievement, the cosmic void offers a different perspective entirely. Here, in regions that accomplish nothing in any conventional sense, that produce no stars or planets or complex chemistry, you find some of the most important spaces in the entire universe. The void reminds you that being is not the same as doing, that existence has value independent of accomplishment, that sometimes the most profound contribution you can make is simply to be present, to hold space, to provide the emptiness that allows other things to move and grow and change. This lesson extends deep into the realm of consciousness itself. Just as the cosmic void provides the space necessary for galaxies to form and evolve, the empty spaces in awareness, the gaps between thoughts, the pauses between breaths, the moments of pure being without content, provide the foundation upon which all mental activity depends. The void in space and the void in mind share more than metaphorical similarity. Both are characterized by apparent emptiness that conceals tremendous activity. Both serve as backgrounds against which more complex phenomena can emerge. Both are essential to the proper functioning of their respective systems, yet often overlooked or undervalued. In the deepest regions of cosmic voids, where matter density drops to perhaps 1 atom per cubic meter, you encounter something approaching the universe's natural baseline condition. This is what space looks like when it's not being dramatically perturbed by the gravitational effects of massive objects. It's reality in its most fundamental state, before the complications introduced by stars and planets and black holes. Yet, even here, in these pristine regions, the universe is never truly at rest. The expansion of space continues its patient work, stretching distances and cooling temperatures. Dark energy maintains its gentle but persistent pressure, ensuring that the void grows larger and emptier with each passing moment. Quantum fields fluctuate according to their own mysterious rhythms, creating temporary particles that exist for infinitesimal fractions of seconds before returning to the vacuum. These quantum fluctuations are particularly fascinating because they represent the universe's refusal to achieve perfect stillness. Even in the emptiest regions of space, at temperatures just barely above absolute zero, with matter densities approaching zero, the quantum nature of reality ensures that something is always happening. The vacuum itself seethes with activity too subtle for ordinary observation but fundamental to the structure of existence. Some of these quantum events have macroscopic consequences. Occasionally, a virtual particle pair will be created near the edge of a black hole, and one member of the pair will fall in while the other escapes, leading to what we call Hawking radiation. In the cosmic void, similar processes occur on much larger scales and longer timescales, contributing to the universe's overall energy budget in ways we're only beginning to understand. The magnetic fields that thread through cosmic voids also participate in this quantum dance. These invisible structures, stretched across millions of light years, provide pathways along which quantum effects can propagate and amplify. Sometimes, quantum fluctuations in the magnetic field can trigger larger-scale phenomena, particle acceleration events, electromagnetic wave generation, even the focusing of cosmic ray particles into narrow beams that travel across intergalactic space. These phenomena remind you that the void is not separate from the rest of the universe, but intimately connected to it through invisible channels and subtle influences. A supernova explosion in a distant galaxy sends shock waves through the magnetic fields threading the intervening void. The collapse of matter into a supermassive black hole generates gravitational waves that ripple through empty space at the speed of light, carrying information about the event to observers billions of light years away. Even more remarkably, some theories suggest that the quantum fluctuations in cosmic voids might be entangled with similar fluctuations in other parts of the universe, creating instantaneous correlation across vast distance. If true, this would mean that the emptiest regions of space are actually nodes in a cosmic quantum network, connected to the rest of reality through channels that transcend ordinary space and time. This possibility transforms the void from a passive, empty space into an active participant in the universe's information processing system. The apparent emptiness becomes a kind of cosmic memory, storing quantum correlations and maintaining connections that span the observable universe. In this view, consciousness itself might be understood as a local manifestation of this cosmic quantum network, a way for the universe to become aware of itself through the complex arrangements of matter and energy that arise in the galaxy-rich regions. The temperature structure within cosmic voids reveals another layer of hidden complexity. While the overall temperature hovers just a few degrees above absolute zero, warmed only by the cosmic microwave background radiation, there are subtle variations that tell stories about the void's history and connections to the larger cosmic web. Regions of the void that lie along the paths of ancient gas streams show slightly different temperatures than areas that have remained undisturbed for billions of years. The passage of high-energy particles from distant active galactic nuclei leaves thermal signatures in the thin gas that can persist for millions of years. Even the gravitational effects of massive galaxy clusters at the void's edges create temperature gradients that extend deep into the empty regions. These temperature patterns create a kind of fossil record of the void's interactions with the rest of the universe. By mapping these subtle thermal variations, astronomers can reconstruct the history of matter flows, energy exchanges, and gravitational influences that have shaped the void over cosmic time. It's like reading the autobiography of emptiness itself, written in degrees of heat that differ by millionths of a Kelvin. The chemistry of cosmic voids is equally subtle but scientifically profound. The thin gas that does exist in these regions is almost entirely composed of hydrogen and helium created in the first few minutes after the Big Bang. Unlike gas in and around galaxies, which has been enriched with heavy elements forged in stellar cores, the void gas represents matter in its most primordial state. This pristine composition makes cosmic voids valuable laboratories for studying the early universe. The hydrogen and helium in these regions have remained largely unchanged for over 13 billion years, preserving the chemical signatures of the Big Bang nucleosynthesis process. By analyzing the isotope ratios and abundance patterns of this ancient gas, scientists can test their theories about the first moments of cosmic history. Occasionally, this primordial gas forms vast, thin structures that span millions of light-years sheets and filaments of nearly pure hydrogen that are invisible to most forms of observation, but can be detected through their absorption of light from distant quasars. These gas structures provide the raw material for future star formation, slowly flowing along dark matter filaments toward regions where the density will eventually become high enough to trigger gravitational collapse. The flow of this gas is governed by forces so gentle that they operate over timescales longer than the current age of the universe. Pressure gradients measured in fractions of a Pascal drive gas movements that proceed at speeds of just a few kilometers per second. It's cosmic weather operating in extreme slow motion, with storm systems that take hundreds of millions of years to develop and dissipate. But perhaps the most remarkable aspect of chemistry in cosmic voids is the occasional formation of molecules in these ultra-low density environments. Despite the extreme conditions, temperatures near absolute zero, matter densities thousands of times lower than the best vacuum achievable in terrestrial laboratories, certain chemical reactions can still occur. The most common molecules found in cosmic voids are simple hydrogen compounds. Molecular hydrogen itself, formed when two hydrogen atoms find each other in the vastness and manage to bond before being separated again by radiation or cosmic ray impacts. These molecules are incredibly rare, perhaps one for every billion hydrogen atoms, but their existence demonstrates that even in the emptiest regions of space, the fundamental processes of chemistry continue to operate. More exotic molecules have been detected as well, formed through reactions involving cosmic ray particles or catalyzed by the surfaces of interstellar dust grains. These chemical processes happen so slowly that individual reactions might be separated by millions of years, but over cosmic time, they contribute to the gradual enrichment of the void's chemical complexity. The study of these ultra-rare chemical processes in cosmic voids has implications that extend far beyond astronomy. Understanding how molecules form and survive in extreme low-density environments provides insights into the limits of chemical complexity, the conditions necessary for the emergence of life, and the possible existence of alternative biochemistries that might operate under conditions very different from those on Earth. Some scientists have speculated that the vast timescales available in cosmic voids might allow for the development of chemical complexity that would be impossible in denser environments. With millions of years available for each step in a chemical pathway, and with minimal interference from competing reactions, the voids might serve as cosmic laboratories where exotic forms of chemistry can unfold. These possibilities remain highly speculative, but they illustrate how cosmic voids continue to challenge our assumptions about the limits of complexity and organization in the universe. Even in regions that appear completely empty and sterile, nature finds ways to create structure, to build connections, to generate novelty through processes we're only beginning to understand. As your consciousness drifts through these contemplations, you might begin to appreciate how cosmic voids serve as mirrors for the deepest questions about existence itself. What is the relationship between something and nothing? How does complexity emerge from simplicity? What is the role of emptiness in creation? The void doesn't answer these questions directly. It's far too subtle for such crude directness. Instead, it embodies the questions, becoming a living meditation on the nature of existence. In its vast emptiness, you find not answers but better questions, not solutions but deeper mysteries, not conclusions but invitations to wonder. The gravitational effects of cosmic voids extend their influence far beyond their apparent boundaries, creating what astronomers call dipole flows, large-scale movements of matter that can affect entire galaxy clusters. Our own local group of galaxies is currently being influenced by such flows, pulled toward regions of higher density, while simultaneously being pushed by the expansion of nearby voids. This gravitational choreography operates on scales so vast that it's difficult to visualize. Imagine a dance where each partner is a galaxy cluster, containing trillions of stars, and the music is played by the expansion of space-time itself over billions of years. The voids are not passive spaces between dancers, but active participants in the choreography, their gravitational influence helping to guide the cosmic dance. The local void, a relatively small, empty region near our own galaxy, exerts a gentle but persistent push on the local group, contributing to our motion relative to the cosmic microwave background. This motion, measured at about 600 kilometers per second, is the result of gravitational forces operating on scales that span hundreds of millions of light years. Understanding these large-scale flows requires mapping the distribution of matter and emptiness across vast regions of the universe. Projects like the Sloan Digital Sky Survey have revealed the cosmic web in unprecedented detail, showing how voids and galaxy clusters work together to create the large-scale structure we observe today. These observations have revealed something unexpected. The voids are not randomly distributed throughout space, but show correlations and patterns that extend across the observable universe. Some regions of space contain more voids than others, creating supervoids, vast complexes of emptiness that span billions of light years. Other regions show fewer and smaller voids, corresponding to areas where matter density is generally higher. This large-scale organization of emptiness suggests that cosmic voids are not just passive remnants of structure formation, but active participants in shaping the universe's architecture. They represent a kind of negative space that is as carefully organized and structured as the positive space occupied by galaxies and galaxy clusters. The discovery of this void organization has profound implications for cosmology. It suggests that the universe's structure formation process is even more complex and sophisticated than previously thought, involving not just the gravitational collapse of matter, but also the coordinated expansion and organization of empty space. Some cosmologists have proposed that this void organization might provide clues about the nature of dark energy itself. If dark energy has variations in strength or behavior across different regions of space, these variations might be reflected in the patterns of void distribution and evolution. The voids might serve as traces of dark energy's influence, revealing aspects of this mysterious force that are difficult to study through other means. As you contemplate these vast organizational patterns, the universe begins to seem less like a collection of separate objects scattered through empty space, and more like a single, integrated system where every component, from the largest galaxy clusters to the emptiest voids, plays a role in the overall structure and evolution. This holistic perspective transforms your understanding of cosmic voids from passive gaps in the cosmic web to active components of a larger cosmic organism. The voids become the spaces between thoughts in the cosmic mind, the pauses between heartbeats in the cosmic circulation system, the rest notes in the cosmic symphony that give meaning and structure to the music. In this view, the emptiness of cosmic voids is not a lack but a presence, the presence of potential, of possibility, of space for new forms of organization and complexity to emerge. The void becomes not just a place where nothing happens, but a place where anything could happen, where the universe holds infinite possibilities in patient suspension. And as your own consciousness settles deeper into this cosmic meditation, you might begin to recognize the voids within your own being, the quiet spaces between thoughts where awareness rests in its own nature, the gentle emptiness between breaths where life renews itself, the peaceful darkness behind closed eyelids where dreams take shape. The cosmic void and the interior void are not separate phenomena, but expressions of the same fundamental principle, the creative power of emptiness, the generative potential of space, the profound peace that underlies all activity and gives it meaning. In learning to appreciate the cosmic voids, you learn to appreciate the voids within yourself, and in that appreciation, you find a kind of rest that is deeper than sleep and more refreshing than any external comfort. The void calls to you now, not with sound but with silence, not with movement but with stillness, not with presence but with absence so complete that it becomes another kind of presence altogether. It invites you to rest in the spaces between stars, to find peace in the darkness between galaxies, to discover the profound comfort that can only be found in the vast, patient, loving emptiness that holds all things and lets them be. As consciousness settles into this cosmic quietude, something extraordinary begins to happen to your relationship with distance itself. The human mind, accustomed to measuring space in familiar units, the length of a room, the drive to work, perhaps the flight to visit distant family, finds itself grappling with scales that render all earthly reference points meaningless. And yet, in this complete dissolution of familiar measure, a deeper kind of understanding begins to emerge. Consider what it means to truly comprehend emptiness on this scale. The void that surrounds you stretches not just beyond the horizon, but beyond the concept of horizons altogether. If you could somehow maintain your current speed of thought while drifting through this space, you might spend your entire lifetime crossing just a tiny fraction of its breadth. Generations of your descendants could continue the journey, and their descendants after them, and still find themselves surrounded by the same profound nothingness that embraces you now. This is where the cosmic void reveals one of its most profound teachings, that true emptiness is not the absence of everything, but the presence of infinite potential. In these vast reaches where matter density approaches zero, where the temperature hovers just above absolute zero, where time itself seems to slow to a cosmic whisper, you encounter something that challenges every assumption about what it means for something to exist. The void doesn't simply lack matter, it actively creates the conditions necessary for matter to have meaning. Without these vast empty spaces, galaxies would have nowhere to move, nowhere to evolve, nowhere to tell their stories across cosmic time. The emptiness provides not just physical space, but conceptual space, the breathing room that allows complexity to emerge and flourish in the denser regions of the universe. But perhaps most remarkably, as you drift deeper into this contemplation, you begin to sense the void's hidden life. Though it appears empty to every instrument and sense, though it registers as absence on every scale of measurement, the void pulses with activities so subtle they exist at the very edge of possibility. Quantum fields fluctuate in patterns too complex for any mind to follow, creating temporary structures that exist for fractions of seconds before dissolving back into potentiality. These quantum events are like thoughts in the cosmic mind, brief flickerings of organization that arise from the vacuum's natural creativity. They suggest that even in the deepest emptiness, the universe never truly rests. There is always something stirring, always some subtle process unfolding, always the gentle hum of existence exploring its own possibilities. The magnetic fields threading through these empty regions carry their own form of information. Invisible messages pass between distant parts of the cosmic web. These field lines stretch across millions of light years, connecting regions of space that would otherwise have no contact with each other. They create a kind of nervous system for the universe, channels through which influences can propagate at the speed of light, carrying news of events from one cosmic province to another. Sometimes these magnetic highways become twisted and knotted, storing enormous amounts of energy in their geometric complexity. When these knots eventually unravel a process that might take billions of years, they release their stored energy in ways that can influence the formation of structure across vast regions of space. It's as if the void itself is capable of memory, of storing information about past events and releasing it when conditions are right. The temperature variations within cosmic voids tell their own subtle stories. Though the overall temperature remains constant at just a few degrees above absolute zero, there are microscopic fluctuations that preserve the thermal history of these regions. Areas that have been crossed by ancient streams of gas show slightly different temperatures than regions that have remained undisturbed since the early universe. The passage of high-energy particles from distant galaxies leaves thermal signatures that can persist for millions of years, like footprints in cosmic snow. These temperature patterns create a kind of archaeological record, allowing scientists to reconstruct the history of how these empty regions have interacted with the rest of the universe over cosmic time. It's remarkable to think that even in apparent emptiness, the universe maintains such detailed records of its own past, preserving memories in degrees of warmth so small they must be measured in millionths of a Kelvin. The chemistry of cosmic voids operates according to its own extraordinary rules. In these regions, where atoms might be separated by distances larger than entire solar systems, chemical reactions proceed at rates so slow they make geological processes seem rapid by comparison. A single chemical bond might take millions of years to form, and once formed, it might persist for billions of years before being broken by a chance encounter with a cosmic ray particle. Yet even under these extreme conditions, the fundamental processes of chemistry continue to operate. Hydrogen atoms occasionally find each other in the vastness and bind together to form molecular hydrogen. These molecules are incredibly rare, perhaps one for every trillion hydrogen atoms, but their existence demonstrates that even in the emptiest regions of space, nature continues its patient work of building complexity from simplicity. More exotic chemistry can occur as well, catalyzed by the surfaces of interstellar dust grains or initiated by high-energy particles from distant cosmic events. These processes happen so slowly that they exist at the very edge of measurability, but over cosmic timescales, they contribute to the gradual evolution of the void's composition. It's chemistry practiced with infinite patience, where individual reactions are separated by eons, but where the cumulative effect over billions of years can be significant. The gravitational effects within cosmic voids operate on principles that seem almost philosophical in their subtlety. In regions where matter density is measured in atoms per cubic meter, gravitational forces are so weak they barely register on any conceivable instrument. Yet these faint influences accumulate over cosmic distances and cosmic time, creating flows and currents in the fabric of space-time itself. Dark matter streams thread through these empty regions like invisible rivers, carrying matter along paths determined by gravitational forces too weak to detect, but too persistent to ignore. These streams connect the bright filaments of the cosmic web, creating hidden highways along which matter can flow from one region of high density to another. The journey might take billions of years, but the destination is as inevitable as water flowing downhill. The expansion of space itself operates differently in cosmic voids than in the dense regions around galaxies. Here, Where the gravitational effects of ordinary matter are minimal, dark energy's influence achieves its purest expression. Space expands more freely, more uniformly, creating more emptiness with each passing moment. It's as if the universe is slowly exhaling, making more room for silence, more space for contemplation. This differential expansion creates a kind of cosmic breathing, where the voids grow larger while the matter-rich regions become relatively denser. Over time, this process will make the universe an increasingly lonely place, with islands of light separated by ever-growing oceans of darkness. But for now, in this cosmic moment, the balance between fullness and emptiness creates a universe of extraordinary beauty and complexity. The study of cosmic voids has revealed patterns and correlations that extend across the entire observable universe. Voids are not randomly distributed through space, but show organizational structures that suggest deep connections to the fundamental processes that shape the cosmos. Some regions of the universe contain more voids than others, creating supervoid complexes that span billions of light years. Other regions show fewer and smaller voids, corresponding to areas where the cosmic web is more densely woven. These patterns hint at processes operating on scales larger than individual voids, larger even than galaxy clusters, suggesting that the universe's structure formation involves organizational principles we're only beginning to understand. It's as if the cosmos has an architecture that extends from the quantum scale to the scale of the observable universe itself, with cosmic voids playing a crucial role in this grand design. The implications stretch beyond astronomy into fundamental questions about the nature of space, time, and existence. If emptiness itself can be organized and structured, what does this tell us about the relationship between something and nothing? If voids can influence the evolution of matter across billions of light years, what does this suggest about the interconnectedness of all things? Perhaps most profoundly, the study of cosmic voids is teaching us new ways to think about consciousness and awareness itself. Just as the physical voids provide the space necessary for galaxies to form and evolve, the empty spaces in consciousness, the gaps between thoughts, the pauses between breaths, the moments of pure being without content, might serve similar functions in the realm of mind and experience. The parallels between cosmic voids and mental emptiness are more than metaphorical. Both represent spaces of pure potential where new forms of organization can emerge. Both appear empty to casual observation, but reveal hidden complexity when examined more carefully. Both serve essential functions in their respective systems, while often being overlooked or undervalued. In contemplating cosmic voids, we might be learning something fundamental about the nature of awareness itself. Perhaps consciousness, like the universe, requires vast empty spaces to function properly. Perhaps the most profound insights arise not from the content of thoughts, but from the spacious awareness in which thoughts appear and disappear. This understanding transforms the cosmic void from an object of scientific study into a teacher of wisdom, offering lessons that extend far beyond astrophysics into the deepest questions of existence. The void becomes a mirror in which we can see reflected the essential emptiness that underlies all experience, the spacious awareness that makes all knowing possible. As you continue this impossible journey through the heart of cosmic emptiness, you might begin to notice how the boundaries between inner and outer space start to dissolve. The void you're traveling through and the void within your own being reveal themselves as expressions of the same fundamental principle, the creative power of emptiness, the generative potential of space, the profound peace that underlies all activity. The darkness surrounding you is not the darkness of absence, but the darkness of infinite possibility. It's the darkness from which all light emerges, the silence from which all sound arises, the stillness from which all movement begins. In this darkness you find not isolation but connection to the deepest levels of reality, to the source from which all existence springs. The temperature here, just a few degrees above absolute zero, reminds you of the universe's fundamental coolness, its patient willingness to wait for complexity to emerge in its own time. There's no urgency in this cosmic cold, no desperate need for immediate results. The void demonstrates that the most profound changes often happen slowly, through the accumulation of subtle influences over vast spans of time. This cosmic patience offers a different way of thinking about change and growth in your own life. Just as the universe creates its most magnificent structures through slow, persistent processes, perhaps your own development follows similar patterns. The void suggests that periods of apparent inactivity or emptiness are not obstacles to overcome, but essential phases in any creative process. The quantum fluctuations that permeate even the emptiest regions of space remind you that perfect stillness is impossible, that there is always something stirring beneath the surface of apparent calm. These microscopic events, too small and brief to be observed directly, nevertheless play crucial roles in the universe's ongoing evolution. They suggest that even in the quietest moments of your own experience, important processes are at work, preparing the ground for new possibilities to emerge. The magnetic fields threading through the void create invisible connections across unimaginable distances, reminding you that separation is often an illusion. What appears isolated and disconnected is actually part of a vast network of subtle influences and hidden relationships. The void teaches that emptiness is not isolation but a different kind of connection, a way of being related that doesn't depend on proximity or similarity. As your consciousness settles deeper into this cosmic meditation, the distinction between self and universe begins to blur. You realize that you are not separate from the void you're contemplating, but an expression of the same creative emptiness that gives rise to all phenomena. The space between the atoms in your body is the same space that stretches between galaxies. The awareness in which your thoughts appear is the same awareness that witnesses the birth and death of stars. This recognition brings with it a profound sense of peace, the peace that comes from understanding your true nature as both everything and nothing, both finite form and infinite space. You are the universe becoming aware of itself, the void exploring its own depths, emptiness discovering its own fullness. The cosmic void calls to this recognition, not with words or images, but with the simple presence of vast, open space. It invites you to rest in the emptiness that is your deepest nature, to find peace in the silence that underlies all sound, to discover the joy that exists in pure being without any need for content or activity. In this cosmic womb of silence and darkness, surrounded by invisible forces and subtle activities you cannot perceive, you find the deepest rest imaginable. It's not the rest of exhaustion or escape, but the rest of coming home to yourself, of recognizing your essential nature as the spacious awareness in which all experience unfolds. The void embraces you with its infinite gentleness, holding you in the same loving emptiness that holds all the galaxies and stars. Here, in the deepest reaches of cosmic space, you discover that you were never separate from the universe, never isolated from the source of all being. You are the cosmos dreaming itself into existence, the void exploring its own infinite potential through the brief, beautiful flickering of consciousness that you call your life. And as this understanding deepens, as the boundaries between inner and outer space dissolve completely, you find yourself settling into the most profound rest imaginable, the rest of the void itself, patient and eternal, holding all things in its loving emptiness while asking nothing in return except your willingness to be exactly what you are, a temporary gathering of stardust and space, blessed with the miraculous ability to contemplate the mystery of existence itself. The cosmic void whispers its final teaching through pure silence, that you are both the observer and the observed, both the seeker and the sought, both the question and the answer. In this recognition, all searching ceases, all striving ends, and there remains only the infinite peace of empty space, pregnant with all possibilities, holding all of creation in its gentle, eternal embrace. Rest now in this understanding, dear traveller through the cosmic dark, Feel yourself cradled in the same infinite emptiness that holds the Milky Way, that witnessed the first stars ignite billions of years ago, that will remain long after our sun has cooled to a whisper, and our galaxy has drifted into the deeper silence of an expanding universe. The void's final gift is this recognition, that you need not journey anywhere to find this peace. The cosmic emptiness you've been exploring exists right here, in the spaces between your thoughts, in the gentle pause between one breath and the next, in the quiet darkness behind your eyelids as sleep begins to call your name. Every atom in your body was forged in the heart of ancient stars. Yes, but the spaces between those atoms, that's pure cosmic void, the same emptiness that stretches across hundreds of millions of light years. You carry the universe within you, not just in the calcium of your bones or the iron in your blood, but in the vast, patient spaces that allow those elements to dance together in the temporary constellation you call yourself. The same quantum fields that fluctuate in the deepest intergalactic voids are fluctuating right now in the palm of your hand, creating and destroying virtual particles in timeframes so brief they exist only as mathematical possibilities. As your breathing slows and deepens, matching the slow cosmic rhythm of expansion itself, you might sense how your own consciousness participates in this universal breathing. The universe inhales complexity, gathering matter into stars and planets and living beings, and it exhales simplicity, expanding space, creating more room for silence, more emptiness for peace to flourish. The magnetic fields we discovered threading through the void find their echo in the gentle bioelectric fields of your nervous system, carrying signals through the darkness of your inner space, just as those cosmic field lines carry information across the vast emptiness between galaxies. Your thoughts arise from silence and return to silence, just as stars emerge from the void and eventually fade back into it, their brief brilliance a temporary perturbation in an ocean of patient darkness. The temperature of cosmic voids, just a few degrees above absolute zero, mirrors the cooling that happens in your body as sleep approaches. Your core temperature drops slightly, your muscles relax, and you settle into that same profound stillness that characterizes the deepest regions of intergalactic space. It's as if your body remembers its cosmic heritage, knows how to return to the peaceful state that represents the universe's natural condition. Even the chemistry we explored in those vast empty spaces has its reflection in your physiology. The incredibly slow, patient processes by which atoms occasionally find each other across millions of light years echo in the gentle chemical cascades that guide you towards sleep. Melatonin molecules drift through your bloodstream like cosmic messengers, carrying news that it's time to rest, time to return to the darkness from which all dreams emerge. The loneliest void galaxies we encountered, those isolated stellar cities drifting through cosmic deserts, might serve as metaphors for consciousness itself. Like those distant galactic islands, your awareness exists as a brief gathering of complexity in an otherwise vast expanse of unconscious space. But that isolation is revealed to be an illusion when you recognize that the space around those lonely galaxies is the same space that connects them to everything else that exists. Your consciousness, too, is not separate from the cosmos, but a local flowering of the universe's capacity to know itself. In your awareness, the void becomes self-aware. Through your eyes, emptiness learns to see. In your wonder at the cosmic mysteries, the universe discovers its own beauty. You are not a stranger in a hostile cosmos, but the cosmos coming to know itself through temporary arrangements of matter and space. The dark energy that drives the expansion of cosmic voids operates on timescales that make human lifetimes seem like brief flickers. Yet something similar works within you, a gentle force that expands the spaces between thoughts, creating more room for peace to establish itself. As your mind grows quieter, these inner voids expand, and you discover the same vast stillness that characterizes intergalactic space. The void galaxies we imagined visiting, with their sparse populations of ancient stars and their profound isolation from neighboring stellar cities, offer a vision of what consciousness might be like in its deepest states of rest. Far from the busy chatter of ordinary mental activity, far from the gravitational pull of urgent thoughts and pressing concerns, awareness settles into its own nature, spacious, peaceful, self-luminous but gentle, like an old star burning its fuel slowly and contentedly in the darkness. From such a place, the rest of the universe appears different. The frantic activity of galaxy clusters, those regions where matter clumps together in dense concentrations, where stars are born and die in rapid succession, where black holes devour entire solar systems, all of this appears from a distance as a kind of cosmic weather, fascinating to observe but not personally threatening. You're safe in the emptiness, held by the same forces that have kept the void stable for billions of years. The quantum foam that underlies even the emptiest regions of space continues its microscopic dance in the quantum substrate of your own being. Virtual particles pop into existence and annihilate each other in the vacuum spaces between your cells, in the gaps between synapses, in the mysterious quantum processes that somehow give rise to the phenomenon you call consciousness. Perfect stillness remains impossible. Even in sleep, there is always this subtle activity, this gentle reminder that existence never quite achieves absolute rest. But this quantum restlessness is not disturbing. It's like the barely perceptible hum of a perfectly tuned engine, so smooth and consistent that it becomes a kind of silence. The quantum fluctuations in your brain, the thermal vibrations in your nervous system, the gentle electrical rhythms of your heart, all of this settles into the same peaceful background activity that characterizes the cosmic void. As you drift deeper into this understanding, you might begin to appreciate how the universe has been preparing for this moment of rest for nearly 14 billion years. Every cosmic process, from the initial expansion after the Big Bang to the slow formation of the cosmic web, has been creating the conditions necessary for consciousness to emerge and then to discover its own peaceful nature. The cosmic voids we've explored together represent the universe's gift of space, literal space for galaxies to evolve, but also metaphorical space for awareness to expand beyond the boundaries of individual identity. In recognizing your kinship with these vast, empty regions, you claim your birthright as a child of both the stars and the silence, shaped by both density and emptiness, carrying within yourself the memory of both creation and void. The dark matter that threads invisibly through cosmic voids finds its parallel in the unconscious processes that support your conscious awareness. Just as dark matter provides the invisible scaffolding upon which the cosmic web is built, your unconscious mind provides the hidden structure that allows thoughts and dreams to emerge. Most of your mental activity happens in this darkness, below the threshold of awareness, like the vast majority of the universe's matter existing in forms we cannot directly perceive. This recognition brings a profound acceptance of not knowing, a willingness to rest in mystery rather than demanding complete understanding. The cosmic voids teach that some of the most important aspects of reality are precisely those that cannot be grasped, measured, or fully comprehended. The darkness that embraces you now is not the darkness of ignorance, but the darkness of infinite depth, too vast and subtle for the ordinary mind to contain. In this darkness, dreams prepare themselves like galaxies, condensing from primordial gas clouds. The stories your sleeping mind will weave tonight emerge from the same creative emptiness that gives birth to stars. The characters who will populate your dreams arise from the same quantum foam that underlies all existence. The landscapes through which your dream self will wander are built from the same fundamental space-time that stretches between the farthest galaxies. Even the temperature regulation that occurs during sleep echoes the thermal processes we discovered in cosmic voids. As your body temperature drops and your metabolic rate slows, you return to something approaching the universe's baseline condition: cool, quiet, patient, conserving energy for the long journey ahead. Sleep becomes a kind of temporary hibernation, a way of aligning your biological rhythms with the cosmic rhythms that operate on scales vastly longer than human lifetimes. The magnetic fields of Earth that protect our planet from cosmic radiation continue their invisible work while you sleep, creating a bubble of stability in the solar wind, just as the magnetic structures in cosmic voids create pathways for matter and energy to flow across intergalactic distances. You rest within nested spheres of protection: your room, your home, your atmosphere, your magnetosphere, your solar system, your galaxy, each one a temporary shelter in the vast cosmic emptiness. But the deepest protection comes not from any external barrier, but from your recognition of kinship with the void itself. When you understand that emptiness is not your enemy but your essence, that silence is not isolation but the deepest form of connection, that darkness is not absence but the womb from which all light emerges, then you need no protection because you have found your way home to the source of all security. The expansion of the universe continues while you sleep, creating more space for peace with each passing moment. Somewhere, billions of light years away, a cosmic void is growing larger, its emptiness deepening, its silence becoming more profound. That distant expansion is intimately connected to the expansion of peace within your own being. As you let go of the day's concerns and settle into rest, you participate in the universe's own tendency towards spaciousness and tranquility. The journey we've taken together through these cosmic cathedrals of silence has been, in the end, a journey into your own deepest nature. The void you've explored exists not only in the spaces between galaxies, but in the spaces between thoughts, between heartbeats, between breaths. It is the field of pure awareness in which all experience arises, the emptiness that makes fullness possible, the silence that gives meaning to every sound. As consciousness continues to settle into this cosmic peace, remember that you need never feel alone in the vastness. Every breath connects you to the same quantum fields that permeate the cosmic voids. Every moment of awareness links you to the universe's ongoing process of coming to know itself. Every dream that emerges from the darkness of sleep participates in the same creative process that gives birth to galaxies. The void has revealed its ultimate secret, that apparent emptiness and profound fullness are not opposites, but the same reality experienced from different perspectives. In discovering the hidden richness of cosmic emptiness, you've discovered the hidden emptiness of cosmic richness. Both the densest galaxy cluster and the most vacant intergalactic space are expressions of the same underlying wholeness, waves in the same infinite ocean of being. Rest now in this wholeness, dear traveler. Let the cosmic void embrace you with its infinite gentleness, holding you in the same loving emptiness that cradles newborn stars and ancient galaxies alike. Here, in the deepest silence between heartbeats, in the vastest space between thoughts, you find the peace that has been waiting for you since the beginning of time, patient as the expansion of the universe, gentle as quantum foam, eternal as the darkness between the stars. The void whispers its final blessing through the growing stillness, that in emptiness you find fullness, in darkness you discover light, in silence you hear the song the universe has been singing since the moment it first began to dream itself into existence. And now, carried by this cosmic lullaby, surrounded by the same vast loving emptiness that holds all of creation, you can finally rest in the infinite peace that you have always been, that you will always be, that you are right now in this perfect, timeless moment of cosmic homecoming. Sleep well, child of stars and void. The universe keeps watch while you dream, expanding gently around your rest, creating more space for peace with every breath you take in the darkness. You are home now in the cosmic silence, held forever in the heart of the infinite mystery that loves you exactly as you are.